Hello, I missed you. I just bumped the chair on my side, but it's fine. Okay, so homework help for 2.1. Here we go. It is right here. Okay, so the first 6, you had to make a point on the vertex, and then draw a dotted line for the axis of symmetry, label the coordinates of the vertex, and state whether it's max or min, write the equation for the axis of symmetry. That is a lot. Okay, so I think Mr. Byrne did the first one, but I'll just go ahead and do it anyway. So I'm going to make a point on my vertex. Bear with me. See how the point actually turns out. Okay, so that's my vertex. All right. I'm just going to go ahead and write the point for it. So the point for that is, most of you got this on the homework, is 0, 0. The vertex is at 0, 0. Okay. I have to draw a dotted line for the axis of symmetry. Okay. So the axis of symmetry goes through your vertex. Boom. 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 Bear with me. Pretend they're straight. You know how this goes. Yeah. Sure. Okay. So there's my there's my axis of symmetry. All right. Oh, state whether it's a max or a minimum. Is 0, 0 the max or the minimum of the graph? Well, the graph never goes below 0, 0, and it's increasing, right? So it's a minimum. Most of you got that as well. And then the equation for the axis of symmetry. The axis of symmetry is just this line. So let me get my little shapes out. I'll actually draw a line there. Oh, it's not going to let me unless I delete that. Okay, hold on. Okay. Work with me. There we go. Okay, I'm going to draw a line. Okay, there. That is my axis of symmetry. And so the equation for this line is just x equals 0, right? This whole line, x is equal to 0. No, that's not true. It's y. No, it's x. I'm losing my mind. Took a week off. It's x equals 0, right? This whole line is x equals 0. All right, so that's the first one. Let's pick another one to do. We'll do number 5. So I'm going to put a dot on my vertex. Oh, bam. And then, oh, that was a good dot. All right, let's write the point. So that point is at x is 1, y is 3. 1, 3 is my vertex point. And then let's say, is it a maximum or a minimum? Well, it's the highest point on my graph, and the graph is decreasing, right? The graph is going negative, so this is the highest point, so it is my maximum point. And then, oh, the axis of symmetry, I'm just going to draw a line. It's way easier. All right, so my axis of symmetry, oh, I missed it. I'll move it. Goes through the vertex, there. Okay, so that's my axis of symmetry. What that means is if I were to fold this over the line, it would be even, right? They would fold evenly onto each other. I hope that makes sense. This side is symmetrical to this side. Okay. So then let's write the equation. So what that is, x equals 1. On this whole line, x is equal to 1. This whole line. So your equation is just x equals 1. Is that everything? Yes. Okay. Cool. Moving on. Um, 7 and 8, I want you to think about. Well, number 9, it can have, let's go back up. Sorry, I just ate a piece of candy. I should probably drink some water. So it can have one x-intercept, right? When the vertex is on the x-axis, it can have one x-intercept there, or it can intersect it twice. Or it can intersect it never, which doesn't happen in 1 through 6, but it could also intersect it never. So it's either 0, 1, or 2, and that's it. All right. 10. Most of you got this one. Sketch a parabola that has no x-intercepts. Okay. So it has to never touch the x-axis. Never will touch it. So one example of this would be, bear with me, like that. And then it's continuing forever upwards, but it never goes below this point. So that would work. And this would also work. Continuing forever downwards, so it's never going to touch the x-axis. So this one is an example. This one is an example. What have I don't know if anyone did this, but this one would not work. Oh, sorry. Wow, that was a bad parabola. Okay, that one would not work because these lines would continue forever downwards, and so they would cross the x-axis. So that does not work. So you can either have it forever increasing above the x-axis or forever decreasing below the x-axis. Let me get rid of that last one. Erase. Well, that was a terrible eraser. All right. Oh, there it went. Okay. That's 10. All right, here we go. I'm going to go through all of these. Byrne did, I think he did 11 with you. So you have x squared plus 4. Which one of these matches x squared plus 4? All right. Well, really, you could put x. This is a square, right? So they're both x. So x and x. So that's the x squared is this. And then you have plus 4 units. So 1, 1. These are all 1. See what I'm writing here? Yes. 1, 1, 1, 1. Okay, so you have x squared plus 4. So that would be D. Bam. 12, you have x plus 4 squared. Okay, so if it helps me. I'm not good with area models, so I like to label. So this is x, and then these are units. So this is, once again, this is, put it at the top. 1, 1, 1. Oh, sorry, and 1. Okay, each of these is 1. 1. Whatever. Okay, 1, 1, 1, 1. So once again, that's x squared plus 4. Okay, and then x squared plus 4. So that's kind of how you're seeing that pattern. If we were to prove it, we could use real numbers. So let me do 5, I guess. So if this side is 5, this is a square. So then this side is also 5, right? So then 5 squared. So 5 plus 2, 3, 4, 4. Oh. It'd be 25. Oh, actually, that's one of the easiest way to do that. No, we'll just leave it with X's. No, you can do the 5s. 5, 5, 5, and then you'd be adding 4 on, and then you would square all that. So this is x squared plus 4, and then that's how you're going to get all these over here. Okay, and then, so that is B. 13, 4x squared. Actually, we'll do 14 first. 14 is a little bit more straightforward. Okay, well, if this is just x squared, so this is just x squared. X, oops, sorry. And that's on all of them, right? So that's just, you have x squared and you have it 4 times. So 4x squared. That's A. And then, so that leaves this to be C. Let's look at it. So you have 4 and you have 4, but we don't know how long the length is, so we're multiplying 4 by x, so whatever x is. So you have 4x's here, you have 4x's here, so that's 4x squared. That's, yeah, 4x squared. So 4 times whatever the length is, and that's squared. Okay. These guys, I think most of you did well on 15. I don't know. Let me think which one tripped some of you up. You guys actually did really well on these. Let's do 17. Okay, so you're just comparing this table to the original one, which is, which is right here. Okay. I don't really want to graph it. I guess I could. Hold on. I'm going to pause you for a second. Okay, we're back. So, pull back up. So you're comparing the tables. So my y values are actually the same. 941, 0149. Scroll all the way up. 941, 0149. Okay, so my y values are the same. What changes are my x values. I start at -3 and I go up by 1. Whereas number 17, I start at -4 and I go up by 1. So that means the graph stays the same, except instead of starting at -3, well, not, instead of the first point being at -3, it's at -4. So we just shifted to the left. We just shifted 1 to the left. So shifted 1 to the left. Oh, we're supposed to write the equation first. My bad. Then if you're shifting 1 to the left, that's +1, and then squared. Okay. So we're shifting 1 to the left. It's x plus 1 quantity squared. What part of the equation indicates moved? The plus 1 inside the parentheses. Right? Okay. And then, are you supposed to graph it? Does it say you have to? Yeah, we're supposed to graph it. Ugh. Okay, well, I trust you guys know how to graph, so I'm not going to graph it. But just from looking at the table, because it started originally, the other one started at -3. I'll just do that real quick. -3. Well, it started at -3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -3, 9. And this, oh, geez, my bad. Ignore that. And then this one starts at, hold on. I can't see what I'm doing. There we go. This one started at -4, 9. Boom. Okay. So see how I just shifted 1 to the left? So then you draw the whole graph, and it would just be shifted 1 to the left. I guess I'll draw a little sketch of it. It's not going to be accurate. So this one crosses at 0 and 1. Next is 0, it's 1. Next, oh, 0. So you would just, sorry, I can't decide what I want to do. When x is 0, y is 1. When x is 0, y is 1. That's for that graph. For the other graph, it's at 0, 0. The 0, y is 1. When x is 0, y is 0, yeah. So, Okay, and then you would just get your graph in there. Oh, I went through the wrong thing. Whatever. forget the graphic. Okay, yeah. Basically, let's go back to just looking at the table. Sorry. Get rid of my little graph. Maybe. Yep. Okay, so it just shifted one to the left. Forget it. All right, since I kind of made that one hard, let's do number 18. So once again, 941, 019, 0149. Those are the same. Yes. So the y values stay the same. The x values, instead of starting at -3, we're starting at 0. Okay, here, maybe I'll just type the x values in -3. So originally, for f of x, this was -3, 2, 2, -1, this was 0, this was 1, this is 2, this is 3. Okay, that's easier to see. So these are your original x values. So you see how -3 to 0, that's 3. -2 to 1, that's 3. -1 to 2 is 3. 0 to 3 is 3. 1 to 4, 3. Okay, so once again, we are shifting. We are going to be shifting to, we're shifting to the right. So this would be, x minus 3 quantity squared. All right, that means we are shifting 3 to the right. Okay, these. All right. Burn did this one. I would do it differently than Burn. Oh, hold on. My mom is calling me. 1 second. Okay. By the way, coming after you from my parents' house in Arizona. Happy holidays. And also, they're helping me recover from surgery, which is going quite well. But yeah, I'm in my parents' house. If you were to look over there, there are like pictures of me all over the wall. We're not gonna do that, but we could. Okay, so Burn did this by going. He made it into perfect squares, which is fine, totally fine. You can do that. Square root just means opposite of squaring. So what number times itself is 49? Well, 7 times 7 is 49. So that's 7. What a squared? So then the square root cancels out the squared. So they cancel each other out. So that's just a. And then you have this b to the 6th. So what I would do is I always just separate them out. So I would go, let me see if I can draw this. B to the 3rd, and then B, oh yeah, to the 3rd. I always did that because when you're multiplying, you add. So b to the 3rd times b to the 3rd is b to the 6th. So another way to think of that Mayburn's way is easier. The way I think about it is that means that's b. I'll just draw this in the 3. B to the 3rd. Geez, it's not very user friendly. And then fine. B to the 3rd times b to the 3rd, so that's b to the 3rd. Squared. Didn't you miss me? Okay, b to the 3rd squared. Okay, so b to the 3rd times b to the 3rd is b to the 6th, so this is just b to the 3rd squared. That's the same thing. So once again, the radical is going to cancel out the 2, so you're just left with b to the 3rd. Okay, so then let me type that in. Boom. There we go. B to the third. Okay. Then these 20 through 23 are pretty straightforward. The radical just cancels out the 2. So the radical cancels out the 2. So all you're left with is x plus 13. You just pull what's in the parentheses out. Radical cancels out the 2, right? If you square something, but then you take the square root, you just undo it. So then you're just left with x minus 16. Okay, and then 24. So 9, just go one thing at a time. What's the square root of 9? What number times itself is 9? 3. M squared, the radical is going to cancel out the squared, so you're just left with m. Okay, and then you have all this stuff in the parentheses, but it's all squared. So once again, the radical is just going to cancel out the 2. So you're just left with 2p to the third minus 2. Okay, because you don't change anything. All that happens is, let me make my line a little bigger. Okay, you're just canceling it. The radical cancels out the 2. It's gone. So you just rewrite everything else that's inside the parentheses. All right, and that is it. Woohoo! Sorry, that was rough. First one in a long time. I'll get better at them. All right. Enjoy your week off.